Niacin's potential to protect against Alzheimer's disease is one of its most underrecognized yet promising attributes. Though often overshadowed by more popular brain-supportive nutrients like omega-3 fatty acids, B12, or even curcumin, vitamin B3 plays a foundational role in neuronal energy metabolism, DNA repair, and inflammation control, all of which are central to the prevention and progression of Alzheimer's and other forms of cognitive decline. Epidemiological studies have repeatedly linked higher dietary intake of niacin with a reduced risk of Alzheimer's disease and age-related cognitive decline. For instance, data from the Chicago Health and Aging Project found that older adults with the highest intake of niacin from food sources had a significantly lower risk of developing Alzheimer's compared to those with the lowest intake. This correlation has been replicated in other cohorts, suggesting a consistent neuroprotective association. However, niacin's role is rarely emphasized in clinical settings or public awareness campaigns, which tend to prioritize newer or more commercially prominent interventions. Mechanistically, niacin influences brain health through several overlapping pathways. At the cellular level, its role as a precursor to NAD+ is critical. NAD+ is required for the activity of enzymes that maintain genomic stability and mitochondrial function, both of which deteriorate in Alzheimer's disease. Mitochondrial dysfunction is now considered a major early event in a cascade that leads to neuronal degeneration. NAD+ is also necessary for the activity of sirtuins, a family of enzymes involved in DNA repair, inflammation modulation, and synaptic plasticity. These enzymes help neurons survive under stress and may even delay the accumulation of amyloid plaques and tau tangles that are hallmarks of Alzheimer's pathology. In addition, niacin influences cerebral blood flow and neurovascular integrity. By promoting endothelial function and reducing oxidative stress in blood vessels, it helps ensure that the brain remains well oxygenated and nourished, factors that decline with age and are impaired in dementia. Chronic inflammation, another hallmark of Alzheimer's, is also mitigated by niacin, particularly niacinamide, which suppresses pro-inflammatory cytokines and glial cell activation. Furthermore, recent research has revealed that NAD+ levels naturally decline with age, and this drop correlates with reduced cognitive performance. Restoring NAD+ levels via niacin supplementation has been shown in animal models to improve memory, enhance neurogenesis, and slow neurodegeneration. Notably, while newer NAD+ precursors like nicotinamide riboside (NR) and nicotinamide mononucleotide (NMN) have gained attention in anti-aging research, niacin itself, especially niacinamide, is a reliable, bioavailable, and cost-effective option that activates the same biological pathways. Despite this compelling biochemical rationale and growing scientific interest, niacin's neuroprotective role has not yet been fully integrated into Alzheimer's prevention strategies. This is partly due to a tendency in both the medical field and the supplement industry to gravitate toward novel compounds, often ignoring older, well-established nutrients. It is also likely influenced by historical concerns over high-dose niacin side effects, particularly the skin flushing caused by nicotinic acid. These concerns, while valid in some contexts, do not apply to niacinamide, which does not cause flushing and is the preferred form for brain support. Another issue is the siloed nature of medical disciplines. Neurology, psychiatry, and nutrition are often separate domains, leading to fragmented views of how micronutrients like niacin influence complex neurobiological conditions. Alzheimer's disease is increasingly recognized as a multifactorial disorder involving not only amyloid pathology, but also mitochondrial impairment, chronic inflammation, metabolic dysfunction, and vascular decline, all areas where niacin plays a quiet yet vital role. In practical terms, ensuring adequate niacin intake through diet and, when appropriate, supplementation could be a low-cost, accessible way to support cognitive aging. Foods rich in niacin such as poultry, fish, beef liver, peanuts, brown rice, and whole grains should be emphasized, especially in older adults whose nutrient absorption may decline. For those at risk of cognitive decline or with early signs of memory loss, niacinamide supplementation in moderate doses may offer neuroprotective benefits without the side effects associated with high-dose nicotinic acid. In summary, while omega-3s and B12 justifiably receive attention in brain health discussions, niacin deserves a more prominent place at the table. Its ability to enhance mitochondrial efficiency, reduce inflammation, support DNA repair, and preserve cerebral function makes it a silent ally in the fight against neurodegeneration. As Alzheimer's continues to rise globally and conventional treatments offer only modest benefits, rediscovering the power of foundational nutrients like niacin could be a vital step forward in both prevention and cognitive resilience.